In 7.4, we'll be talking about exponential growth and decay. So we want to review a little bit about exponential growth and decay. So here's our general formula. We have n of t, which represents in some cases, the amount remaining of a particular time of a population. N subscript 0 or n naught is the initial population. And then k represents a constant and t represents time. Now, if k is greater than 0, if it's positive, then it's going to be an exponential growth. If k is less than 0, then it's going to be an exponential decay. So, for example, let's say that in the year 1990, the initial population is 16,400. And then in year 2000, it has grown to 20,200. So, if we wanted to solve for k, given this information, well, we know that n of t, meaning the population in 2000, is 20,200. N naught, or the initial population, is 16,400. And to find the time t, you're going to take 2000 and subtract 1990, which gives us 10 years. So now we're going to plug in that information. So we end up with 20,200, which equals the initial population, 16,400, e to the t, which is 10 times k. And so now, in order to solve for k, we're going to divide both sides by 16,400. And then we can take the natural log of both sides. And then in this scenario, we know that we have a base of e, so we're going to have 10k, and we're going to divide both sides by 10. So therefore, k is going to equal the natural log of 20,200 divided by 16,400. And when we find that approximation, we're going to get 0.0208. So because this is positive, then this is going to represent a growth model. And so in order to write the growth model, what we're going to do is we're going to write it into our general form. So in number 2, we have n of t, which is equal to 16,400, which is the initial population, e to the constant k, which is 0.0208t. Now let's say if we wanted to find the population for 2005. Then what we're going to do is we're going to take 2005 and subtract the initial year, which is 1990, to give us 15. So we're going to find n of 15. We're going to plug it into our function now, which is going to be 16,400 e to the 0.0208 times 15, which approximately gives us 22,400 as far as the population is concerned. And this is rounded to the nearest hundred.